Have you ever wondered if teleportation and wormholes are real? Well, get ready to take a journey through the fascinating world of quantum physics and theoretical astrophysics. In this video, we will explore the science behind teleportation and wormholes, and we'll see if they could one day become a reality. Teleportation is the concept of transferring matter from one location to another instantaneously, without physically moving through the intervening space. It is often portrayed in science fiction as a means of transportation, where a person or object is disintegrated at one location, transmitted through some form of energy or signal, and then reassembled at another location. Wormholes are theoretical tunnels in space-time that connect two distant points. They were first proposed by physicist John Wheeler in the 1950s as a solution to Einstein's theory of general relativity. The idea is that space-time can be warped in such a way that it creates a shortcut through space, much like a tunnel through a mountain. Wormholes can be described as having two mouths, or openings, that are connected by a throat. The mouths could be in the same location in space or in different parts of the universe. The throat is the narrowest part of the wormhole and could be as small as an atomic nucleus or as large as a galaxy. So, could teleportation be possible in real life? Well, the answer is yes, and it all starts with quantum entanglement. Quantum entanglement is a phenomenon in which two particles become linked in such a way that their properties are correlated. This means that any change made to one particle will affect the other particle, even if they are separated by great distances. Using quantum entanglement, we can teleport information from one place to another. This has already been achieved in the lab, but teleporting large objects, like humans, is still a long way off. But what if we could create a shortcut between 2 points in space? That's where wormholes come in. The idea of a wormhole can be illustrated using a sheet of paper. Imagine that the paper represents space-time. If you fold the paper so that two distant points are touching, you have created a shortcut between those 2 points. This is the basic idea behind a wormhole. In reality, space-time is much more complex than a sheet of paper, but the analogy helps to visualize the concept. The mathematical equations of general relativity describe the curvature of space-time. This curvature can be visualized as a gravity well, where the more massive an object, the deeper the well. A wormhole would be created by manipulating the curvature of space-time in such a way that it creates a bridge between 2 points. Theoretically, there are a few ways that a wormhole could be created. One possibility is to use a massive object, such as a black hole, to warp space-time in such a way that it creates a bridge. Another possibility is to use exotic matter, which has negative mass energy, to manipulate the curvature of space-time. The negative energy of exotic matter would counteract the positive energy of normal matter, allowing for the creation of a wormhole. Creating a stable wormhole would require controlling the intense gravitational forces that would be present. The gravitational forces near a black hole or exotic matter would be incredibly strong, and without some way to stabilize the wormhole, it would collapse almost immediately. Another major obstacle to creating a wormhole is the need for an enormous amount of energy. The energy required to manipulate space-time on such a scale would be orders of magnitude beyond what we are currently capable of producing. Wormholes require a lot of energy to keep them open. We're talking about more energy than we can even imagine. Plus, we don't know if they're stable. They could collapse at any moment, and if you were inside one when that happened, well, it wouldn't be good. Another issue with wormholes is that they could lead to a black hole. If you were to travel through a wormhole and end up in a black hole, well, let's just say it wouldn't be a pleasant experience. So how can we use wormholes for teleportation? The idea of using wormholes for teleportation is based on the concept of entanglement. Entanglement is a quantum phenomenon where two particles become linked in such a way that the state of one particle affects the state of the other, no matter how far apart they are. In theory, if we could create entangled particles and send one through a wormhole to a distant location, the state of the other particle would instantly change, effectively teleporting it to the same location as the first particle. To achieve this, we would need to create a network of entangled particles that span the entire universe. This network would act as a kind of quantum internet, allowing us to send information and objects instantly from one location to another. The key to making this work would be to find a way to create and maintain entangled particles over vast distances, something that is currently beyond our technological capabilities. Let's discover beyond. Portal to unobservable universe. Imagine embarking on a thrilling journey through portals to explore the mysterious realms of the non-observable universe, where the laws of physics are pushed to their limits and reality as we know it is challenged. What if there are aliens living out there, waiting to be discovered? Well, what if I told you that we might have a way to get there? What if we use portals to travel to the non-observable universe and find aliens? Before we dive in, let's first understand what we mean by the non-observable universe. The observable universe is the part of the universe that we can see and observe from Earth. It's estimated to be about 93 billion light-years in diameter. However, there's more to the universe than what we can observe. The non-observable universe is the part of the universe that's beyond the limits of what we can see. So how can we travel to the non-observable universe? Well, that's where portals come in. If we could create and control a portal, we could potentially use it to travel to the non-observable universe. Imagine traveling through a portal and arriving on an alien planet. What would it be like? What kind of life forms would you encounter? Would they be friendly, or would they see you as a threat? Portal to multiverse. The idea of traveling to the multiverse using portals is a popular concept in science fiction and theoretical physics. The concept of a multiverse suggests that there are many universes parallel to our own, each with its own unique set of physical laws and constants. If we were to use portals to travel to the multiverse, it would likely involve creating some kind of bridge or connection between our universe and another. The exact mechanism for creating such a portal is still purely hypothetical, as we do not yet have a complete understanding of the underlying physics that governs the multiverse. Assuming that we were able to create a portal, the experience of traveling to another universe would likely be vastly different from anything we have experienced in our own universe. Depending on the physical laws of the other universe, we could encounter strange and exotic phenomena such as time dilation, extra dimensions, and alternate forms of matter and energy. Portal to another planet. If you were to travel through a portal to another planet with a significantly greater gravitational force than Earth, time dilation would occur. This is because gravity affects the fabric of space-time, causing time to slow down in areas with stronger gravitational fields. According to the theory of relativity, time dilation occurs when an object is moving at a high velocity or is in a region with a strong gravitational field. The closer an object is to a massive body, the slower time passes for that object. Therefore, if you were to travel through a portal to a planet with a stronger gravitational field than Earth, time would appear to move slower for you compared to someone on Earth. The degree of time dilation would depend on the strength of the planet's gravitational field. For example, if you were to travel to a planet with twice the gravitational force of Earth, time would pass at a rate of about 71% of the rate on Earth. This means that for every hour that passes on Earth, only 42 minutes would pass on the planet with greater gravity. There are many scientific challenges that must be overcome to make wormhole teleportation a reality. One of the biggest challenges is the stability of wormholes. According to the laws of physics, wormholes are highly unstable and would collapse almost instantly. To stabilize a wormhole, we would need to find a way to create and maintain exotic matter, a hypothetical substance with negative energy density that could counteract the gravitational forces that would cause the wormhole to collapse. Another challenge is the creation of entangled particles over long distances. Currently, we can only create entangled particles over short distances in laboratory conditions. To create a network of entangled particles that spans the universe, we would need to find a way to create and maintain entanglement over much larger distances, something that is currently beyond our technological capabilities. Despite these challenges, scientists are still studying wormholes and looking for ways to make them a reality. If we could harness the power of wormholes, it would revolutionize space travel and open the universe to exploration like never before. While we're not quite there yet, who knows what the future holds? Perhaps one day we'll be able to travel the universe in the blink of an eye. Until then, keep dreaming big and never stop exploring. We hope you enjoyed this video as much as we enjoyed making it. If you did, please give it a like and share it with your friends. And if you want to see more content like this, make sure to subscribe to our channel.